Welcome back, everyone. Welcome back. All right. You now follow us on a journey to a harmonized and secure data access for simplified application development across all C8 cluster components, and to share how we are going to support your transition to the new and one API to rule them all and set the stage for future innovation. Please join me in welcoming Aleksander, Dytko, and Tobias Metzke.
Hi, welcome everyone. Great to see that so many of you are interested in the API landscape. Cool. So let's check how we forged one API to rule them all and move from fragmented to unified experience with the Orchestration Cluster API. I'm Aleksander. Oh, yeah, that's actually me. I'm Aleksander, product manager here at Camunda, and together with Tobias, senior software engineer, we worked side by side for the last year and a half, defining what the API should deliver and how to build that so that we can support API users with a seamless experience. So over the next 20 minutes, we will share the journey with you and also share the key learnings from this initiative. We'll go back to 2023 and check just how complex things used to be for API users. Then we'll share the vision that guided the cleanup, and we'll check where are we right now with the demo. Finally, we'll move to check what is coming in the future of the APIs, and we'll close with a Q&A. We want everyone here to leave with something actionable, whether you are deep in the code or managing automation at scale. So let's jump into this. Back in 2023, our architecture was component-based. So the orchestration cluster consisted of several different applications. We had Zeebe, Operate, Tasklist, and Identity. Each was running a separate service built by a different component team. And back then, this architecture gave us a lot of flexibility, but it also made the architecture fragmented. And this was visible across the whole stack, starting from a data layer and applications up to APIs and clients. So on the data layer, the data about processes was scattered. So Zeebe, once done with processing, exported the data to Elasticsearch, and then Operate and Tasklist imported the same data twice. And then we exposed this data via APIs, but the problem was that Operate and Tasklist APIs didn't expose the whole data structure, so only some specific properties were exposed. And then this fragmentation became very visible for API users when they wanted to integrate with the entire cluster and build applications that integrated with Zeebe, Operate, and Tasklist, because they had to use 3 different APIs and 3 different clients. So thinking about this architecture and this component-based architecture, it made onboarding, but also implementation more challenging. So users had to use multiple different component-based APIs. So Zeebe, Operate, Tasklist. And this meant that they had to juggle different APIs just to satisfy their use cases. And Felix was talking about identity, and identity didn't provide any public API or client. Clients were another pain point, because each client came with different guarantees. So Zeebe client was built by Camunda and supported by Camunda, but Operate and Tasklist clients were community built and supported. This made the configuration different. So when you wanted to integrate with the entire cluster, you had to integrate and configure 3 different clients for the same cluster. Now, why was that happening? The Conway's law explains it well. So the structure of a software system reflects the communication structure of an organization that builds it. And that was very true in our case, because each component, together with the API, was built by a different component team. So this caused some inconsistencies in the API layer, such as naming, HTTP status codes, or how API features were implemented, such as search or pagination functionality. And this brought some friction during the user journey when implementing the API integration. And on top, there was gRPC. So some customers face adoption blockers with gRPC because the underlying HTTP2 protocol was not enabled and allowed in their networks. So they had to request exceptions just to get started. And even if it was allowed, developers felt it's more difficult to work with gRPC compared with REST API. So let me give you a simple example of these problems. Let's say I want to orchestrate the simple process. So I want to start a process instance, query and complete user tasks, and then once the process instance is completed, fetch process variables. And this sounds simple and should be straightforward, right? Unfortunately, with this API and client fragmentation, it wasn't. So I had to use 3 different clients, 3 different APIs with 3 different configurations. And this didn't just add busy work. It meant onboarding, implementation, maintenance, and support was more difficult. So imagine this. Instead of asking yourself what API, what client, and what protocol to use, the answer is always the same: the Orchestration Cluster API. Our vision was to provide an intuitive, consistent, and secure API experience where every functionality and data in the orchestration cluster leaves behind one REST API. And security is applied consistently across all endpoints, so your data is protected. We wanted to give customers API experience that enables them with a seamless experience when onboarding, but also empowers them for rapid application development. So instead of fighting integration complexity, customers can focus on building business value, so they can very quickly go from deploying a process definition to running processes and jobs at scale. And just saying, let's just clean it up, was the easy part. We had to re-architect not only our system, but also how our product organization works, so that this time the Conway's law plays for us, not against us. So at the high level, what we wanted to do is we wanted to replace different components with just one single application. We wanted to replace this long data pipeline with exporters, importers, and multiple data schemas with just one exporter, one data schema, and one search client. Then we wanted to replace different component-based APIs with a single Orchestration Cluster API. And finally, as cherry on top, replace different component clients with just one Camunda client. So now any product manager in the room knows the next 2 questions. How many people do we need, and how long would it take to implement this change? And usually, any product manager underestimates. Right, Toby?
Yeah, happens sometimes. But no, honestly, we looked into it, we discussed it, because we found out it's imminent, right? We need to do this. And we looked into it, discovered, well, doing this takes us several months at least to build it, 6 to 9 maybe. Looked into it a bit more closely, figured out, well, months might not actually cut it. We might be looking at 1 to 2 years to actually properly re-architect the whole component landscape and get it right. What can I say? That's still the journey we wanted to take, so we took it. And for the past 1.5 years, that's the journey we went on. So let's have a look at how that worked. How do we get from left to right? So we have that component landscape, but we want to have that nice streamlined vision on the right-hand side. The one thing we have to do here is re-architecturing the whole architecture that we have on the left-hand side. So we need to streamline things and re-architecture things. You have seen Felix talk before us, talking about the identity part. You might have seen this last year right here in New York for CamundaCon, where Roman and Felix took us to the revamped developer and installation experience with that re-architecture. We also had this up in Amsterdam this year, where Chris and Nicola took us through the changes in the exporter and the data pipeline, how that improved the lag between exporting from the engine and then down into secondary storage and back to the query API. So there have been a lot of improvements there, and if you're interested in that, hook us up after the talk and we can show you around there. What we want to focus on today is the impact on the Orchestration Cluster API that we want to talk about on that level. One thing we did first was we moved those data pipelines that we have, which is very complex, into one single exporter with one harmonized schema underneath, and building like an abstraction layer as a search client next to it, so that whenever we want to access data from the Orchestration Cluster API, we have an abstract layer we can use. And whatever other data layer we want to support in the future underneath, for example, RDBMS, we don't have to touch the Orchestration Cluster API at all. It's just going to stay the exact same. On top of that, we revamped the application layer. So those 4 applications that you see here, we needed to collect them into one so that we have all the business logic that's scattered across those components into one single application. That means user task handling, for example, went into the process engine. So the whole user task lifecycle is managed in the workflow engine in Zeebe. Identity, as Felix just mentioned and outlined how that looks like, went into the process engine as well. So authorization checks actually happen in the engine. Using that, we could build on top of the single application that we have now, we can then build one API that's nice and shiny on this single application that we have, so you don't have the scattered API experience anymore. So what we did is we built one REST API on top. It's harmonizing and collecting all the features you had in those former APIs. So Zeebe operate and Tasklist API, but you also have identity-related stuff in that API now, right? So you can create users, tenants, assign roles, stuff like that, all in one API, where you can also search for user tasks, create process instances, and whatnot. This is all evolving around one open API spec that you see in green here on that slide. We manually curate that spec, so we're not generating this. A couple of projects do that, right? So you have then server code, and then you generate your API spec depending on what the server does. That's brittle, right? Because that will change over time. So we want to manually create that so it stays stable. And whatever consumer we have for that spec, be it our public documentation that we completely generate from it, be it clients that we generate from it completely. If you want to see that in action, stay here for Josh Wolf's talk right after, because he's generating the Node SDK, for example, from that spec. So all of this needs to stay stable, so that's why we manually actually curate that. With the harmonized access that Felix talked about earlier, with identity being in that single application, every entity, so every resource in that API is accessible and securable with the same permission pattern. So it doesn't matter if it's like roles or if it's user tasks, process instances, all of them follow the same pattern of resource-based authorization. So all of that is harmonized. And to offer that not only on that API level, but also one level up in the client, because a lot of our customers still use Java to develop their tools, we collected all of the functionality into one Camunda Java SDK, as we call it. This also builds on the Open API spec, so all the interaction, all the data transfer objects that we use there, they're generated from that same spec that the server uses, so that they stay in sync. You only have one configuration then, right? So you only need one client to access all of the data in that cluster, which is pretty nice to use. We also realized this is like a real door opener for all of the applications that use it, be it our web modeler, Camunda Play, Camunda Process Test, the connectors. They all use this Java SDK, so they can access now all of the data in a cluster with one client instead of fumbling around with different APIs and trying to make it work. What can I say? Mission complete. We actually made that happen over the past 1.5 years, and we're super proud that we can present this like here today, and we're going to ship this next week with Camunda 8.8. And in case you're wondering, with all the talking about REST APIs, gRPC is still here. So if you need that for any high performance throughput, low latency use cases, you can still use that. We're going to maintain that further. It's going to be baked in there, so it's not going to go away. So that's a lot of high level, how do we do this stuff. Let's maybe look at how that really shiny thing comes to life. So if we go to the browser and hit up the Camunda docs, you're probably familiar with that. I don't want to reload the site. No. So if we look at the docs down at the bottom, you can see the APIs and tools down there. If you head over there, you will see all the different tools that you can use, different APIs. Down there is the Orchestration Cluster API. And if you hit that up, you're going to get a nice overview of, hey, what is this? What are the key features of this? You can browse this on your own if you like. You can see how to fetch data, how to secure it, how to explore it with the Swagger UI that we have in each cluster, for example. You can also have a look at the specifications, meaning all the entities that we actually have in that cluster. So how do I, for example, do stuff with jobs? So I can go there, I can have a look. Oh, I can activate jobs, for example, so I'm going to do that. It tells you how that works, what request attributes you have, if they're required. You can have a look at the responses, how do they look like. In this case, it's an array of jobs. And then you can have a look at what does jobs mean. This is the attributes you have, which ones are guaranteed, stuff like that. So you can explore that all in the API documentation, if you like, and then find out what to do in which cases. What you can also do is, of course, use code. Before we do that, though, you remember that thing, hopefully, which Aleksander put up. It's quite complex, right? So it uses different APIs, different configurations, and it also has engine interaction, creating process instances, then using the secondary storage to find user tasks, then using the engine again to complete it, and then using secondary storage again to find variables in an ended process. It's doable, but not very nice. So with 8.8, we can fix this, and the first thing we should fix is actually not having this engine interaction, secondary storage querying, engine interaction, and then again querying, because that adds latency, and we're dealing with an eventually consistent system, right? So what does that mean? If we have a look at the architecture that's new, there is a process engine in there, right? So and it has its own primary data storage. This is strongly consistent, right? So if you interact with it, you get an answer, and that's directly persisted, and the next time you do something with it, it's there, right? The problem is it also needs to export that data to secondary storage for history storage. So that takes a while. It's asynchronous. So if you interact with the engine first and you get an answer back that's persisted in the engine but not in the storage yet, so if you then right after it try to search for stuff, it might not be there yet. It can take a second, it can take 2 seconds, it really depends on the setup, on the load, stuff like that. So we don't recommend doing this. This will lead to data inconsistencies. You're going to wonder, why is my data not there? Don't do that. What should you do instead? We have seen this on stage actually earlier from the 2 guys from VRD. Use listeners. They are way better suited for this. So execution listeners can do stuff like, hey, if my process instance ends, I want to know, please tell me, and then you're informed in your application and you can do something with it. The cool thing about 8.8 for next week is you can not only do this for execution activities and then start and end, you can do this for user tasks as well. So task listeners will be shipped with 8.8, and you can hook into the whole life cycle of user tasks. So you can have a look at when is my user task created, I want to be informed, and I can do something with it. I can reject it, I can correct what's happening there, I can complete the user task when it's created because I directly want to complete them now, whatever. You can do whatever you want, you get something in your code and you can use that. Let's have a very quick look at how that could look like in code. You can also use this fella, it's going to stay up, and scan it. It's going to get you to a GitHub repository where you can see the code that I'm showing. So real quick, what you can do is in the client, if we hit up that main method here, you need to connect to your cluster, right? If that's local, all you need to do is put up the Camunda client. That's it. That's one line you need. If you need Camunda run, for example, no authentication, one line, your access. You can work on those listeners, as I mentioned, right? So the cool thing about listeners is it's just jobs. It's no special thing. If you have worked with jobs before, it's the same thing. You get a job for each listener event, and then you can work with it. For user task listeners, you actually also get the user task data in that job. So in that handler, you can use the user task data, and you can also use the client to complete user tasks from in there, all those things you can do. Despite that, you can still do things you could do with a Zeebe client, so deploying process definitions, creating instances, stuff like that is still the same, nothing changed. On top, secondary storage interaction is new, right? So the Camunda client also brings that along. Formerly, you only had the community clients to do that. How do you do that? Real quick, let's skip over that, but like the new part is there is search requests now in that client. And from there, you can then filter process user tasks, for example, and say, hey, if I want to have all user tasks for my process instance, but I can also do cool stuff like, hey, it also has to have an assignee, so an assignee needs to exist. I can also say, hey, only those that are not in the created state, stuff like that. So very advanced querying, you can do that directly from the client and use all that. Doing that was, of course, like creating this, and now it looks simple, but it wasn't that easy. So let's have a look at some key feature learnings that we had along the way. If you have a streamlined API, it's becoming a real innovation hub. So internally, when we published this internally, other teams immediately jumped on it. We have agentic stuff in here, like the ad hoc sub-processes, they're in the API now, so they immediately put it in there. We have document handling in there, which is in the API. We never had this in any API before. So it immediately it skyrocketed inside of the company, and people took on it and added stuff. Also, getting consistency right was super hard. So this is like the main learning. If you do something like that, streamlining it, consistency is really the key. So you have to align teams, how to align behavior, namings, all of those things. It's super hard to get right. It needs a lot of communication, which is really super important in such an endeavor. Communication inside to streamline teams, but also externally talking to customers early, get them on board, let them break it, what you're building, right, early on, and then fix it, improve it, iterate, and iterate again, so you break out of that bubble and actually improve it together with customers, together with users, together with internally users, just improve it over time. But that's not where we want to stop, right? So last on the list, let's have a look what's next.
Exactly. So there is more to come. Moving forward, the Orchestration Cluster API is a default API. This means that any new functionality or data that is available in the orchestration cluster is exposed with this API. It's also a recommended way for customers to build process applications and fetch data from the orchestration cluster. We are deeply committed to this API and currently rebuilding our front-end applications, so operate, Tasklist, and identity, to use orchestration cluster exclusively. So you can make sure that any data or functionality that is available in the front-end application is available to you in the same way via the API. And this is just the beginning. So moving forward, we are opening the door for agentic orchestration. We'll build the MCP support, so Orchestration Cluster API will be available to LLMs so that it can fetch data, but also execute actions with process operations. So all of that, it's not just about simplification. It's also about creating a stable foundation for the future of enterprise agentic automation. And we know that with such a big change, there is always some uncertainty. We hope we answered some of your questions already, but we are sure there is more to come. So let's jump into that. Let's answer some of them.
There are questions. There are questions from Slido, and let me also just thank you all for streamlining this new unified API. I, for one, will be very grateful about the effort that you've put in. But to the questions in Slido, first up, will the gRPC APIs still be available as part of this new unified API?
As Toby already presented, gRPC is here to stay. So we'll have the REST API as a default API, but also gRPC is here for like low latency, high throughput use cases. So it's staying.
Perfect. Now, prior to 8.8, we have both an exporter to Zeebe and an importer for operate and Tasklist. Are we removing the importer in 8.8 and just have a single unified exporter?
Yes, that's exactly what we do. That's spot on. The importers are removed, so they keep processing the old stuff, but then from there on, it's one exporter, and that's it.
All right. Next question. Is there a Postman collection for this new API?
There is a Postman collection, which will be updated this week, just before the release, so that we ensure every endpoint that is available in the Orchestration Cluster API is also available in the Postman collection. So for the release for next Tuesday, the Postman collection will be updated.
Perfect. Next up, is there any chance that you will officially support a Python client?
Yes.
If you watch the keynote, that's a clear yes, right? So that's what we want to do. That's why we have that manually curated OpenAPI spec, because you can generate a lot of code for clients from that, and the Python client will just do the same thing.
All right. Next up, what's the best way to trace an instance lifecycle via the Cluster API?
I think as I understand the question, the instance lifecycle, so we mean the process instance is started, it's running, and it's completed. So this can be done with two different approaches. One is the query API, where you can query for process instance state. And another one is with listeners that Toby showed, so that you can add a start and end listener on the process instance level, so that you're notified when the process instance is started and when it's completed.
All right. Next up, now up to version 8.7, we've had each component separately deployed as per a standard microservices architecture with loose coupling. But it looks here like all Zeebe, operate, tasklist, identity is being deployed as a single application. Is it tightly coupled?
Well, yes and no. So the coupling happens in the data layer, basically. So all the application logic is in one application now. So it's one single application. So user tasks that were formerly in Tasklist are now in that workflow engine. Batch operations are now in that workflow engine. There's no separate components handling this. So there's a tighter coupling of the logic. But we don't have those components anymore, actually. So in the backend, at least, there is just one single application. So it's all in one behavioral class, so to say. And that's it. So we don't couple components anymore. We don't have components anymore in the backend. It's just one component. But you can start the front ends that you have on top of them. You can start them up individually if you like, for example.
Beautiful. I love it. Next up, is it also possible to enable TLS for this new API?
That's a short yes.
Yes. And then I think this is our final question. Does API auth integration, for example, with Entra ID, require only one app registration in 8.8?
Felix? Yes.
Yeah, the answer is yes. Well, gentlemen, thank you so much. This has been
Thanks,
a great
Kevin.
presentation.
Thank you.
Really appreciate it.
We just wanted to leave you with this one QR code. So if you're interested into the details, there is a QR code for the API migration guide. So please check it out. Thank you.
All right. Yeah, thank you everyone for staying. We know we started this session a little bit late and therefore ran over. We are now going to transition to what's about a 20-minute break for you all now, up till about 3:40 p.m. When we return, over on stage 1, BP3 Global will demonstrate how to use Camunda and AI to build a compliance monitoring agent that automates risk detection in highly regulated industries. And then back here on stage 2, Camunda's very own Josh Wolf is going to share real-world, battle-tested code patterns from C8 implementations and the development of the Node.js SDK to help developers bridge the gaps left by our official docs. So we'll see you back here in just a little bit.